Welcome to Learn Yourself. Today we are going to study about chapter number 8, Motion. This is under CBSE Standard 9 syllabus. So first of all, we all know that what is a motion. Motion is any movement which is happening with the force, without force, and there are different types of motion. So in this chapter we are going to study what is a motion, what is a displacement, how we are measuring a distance. There are equations for motion and we are going to solve some of the numericals based on this equation. So these basic concepts are important to understand the equation. In turn, we are using them into a numerical. So let us start first with the motion. That what is a motion? Motion is a simple thing which is related to a movement of the body. When any body is moving with force, without force, is considered as a movement, is considered as a motion. Now, what is a magnitude of motion? For example, whenever we are discussing about motion, it is directly associating with the travel or a distance, what we have covered through that movement, will always associated with the motion. So now, whenever we are talking about specific motion, then it always related to a travel. Now whenever it is a motion or whenever it is a travel, we always assign one quantity, a physical number to that. For example, when we have covered distance from A to B, this distance is 5 km. So we have assigned one quantity, one physical quantity or one number to this distance which we have covered. So this number or this distance is a magnitude. So what is a magnitude? Magnitude is any number we are assigning to a distance covered or a movement or a motion. That is a magnitude. It is a physical quantity. Physical quantity means it actually that much distance has been covered by object. So that's why it is physical quantity. And a numerical value. Numerical value means a number. So what is a magnitude of movement? Magnitude of movement is specific number when we are assigning to that distance covered or that movement. So in a simple term, when any movement happen, when any motion happen, when any displacement will happen, at that time we are assigning one physical quantity, one number to that movement, that is known as magnitude. Always whenever we are assigning a magnitude to something, then it is a physical quantity, it is related to the number. So here also we have assigned one number that this body has covered 5 km distance. What will be the magnitude? 5 will be the magnitude of that movement. Now, when we are talking about motion, the two important terms we have to understand. First is a distance, second is displacement. As the name suggests, distance means how much we have travelled and displacement means how much body has transferred from one place to another. So let us go through these two concepts thoroughly. Now let us understand these three cases for displacement and distance difference. So here the first case is in which car has travelled 5 km. From point A to B. The distance between point A and point B is 5 km. So here how much distance car has travelled? So it is 5 km. So the magnitude of distance is 5. So here 5 km it has travelled. Now displacement. What is the displacement? Displacement means anything which is moving from its place. How much it has moved? That is displacement. The name itself suggests that displacement. That how much it has moved from its earlier position. So displacement is a distance from the initial point to final point. So here this is our initial point. And this is our final point. So how much car has moved in between from initial point to final point? So that is also 5 km. So here distance and displacement both are same, that the difference between initial point and final point is also 5. So here distance and displacement is same. Let us check now the second case. In that the distance from A to B is 5 km. So car has started from A, it has reached B, and then again it has come back. So while going it has covered 5 km, and while coming back it has also covered 5 km. So how much distance it has travelled? While going and coming back it is 5 plus 5, so distance will be 10 kilometers. So distance is 10 kilometers because while going and coming back it has travelled 5 kilometers. Now when we are talking about displacement, displacement is the distance between initial position and final position. So car has started from this position and it has reached this position. So actually it hasn't moved from where it has started, it came back to that point again. So here our displacement will be 0. Even though car has covered a distance of 10 km, it has come back to its original position, its initial position. So that's why the displacement is 0. So here in this case displacement can be 0, but distance cannot be. Whenever it is a movement, whenever it is a travel, whenever it is a motion, distance can never be 0. But yes, in such circumstances when the initial point and final point is same, in that case displacement can be 0. Now let us talk about the third case, in which car has travelled from A to B point. So it has covered a 5 kilometers in first journey, then it came back till here, till a point of 2 kilometers. So actually it has travelled 3 kilometers. So now how much distance has been covered from the car? That while going 5 kilometers, and it came back 3 kilometers. It came back 3 kilometers. So actually it has covered 8 kilometers. What will be the distance? Because it has gone till 5 kilometers till B and again came back 3 kilometers. So actual distance has been covered by the car is 5 kilometers plus 3 kilometers. So it is 8 kilometers. Now when we are talking about displacement, displacement is, this is initial position and this is final position. So here from where it has started, here it is 2 kilometers. Here it is 2 kilometers because it has already come till 2 kilometers. It has travelled 3 kilometers. So when we are subtracting this coming back travelled, 5 minus 3, it is 2 kilometers. So here it is 2 kilometers. So its initial position is here and final position is here. So what is the movement of the body? What is the movement of the car? Is actually this much only. Actually this much only. Because what is the displacement? Displacement is the difference of initial position to final position, or distance covered by body from initial position to final position. Even though it has gone till here and come back here, actual movement, earlier it was here, now it is here. So it has covered only 2 kilometers. It has covered only 2 kilometers. So in this case, displacement is 2 kilometers, but the distance is 8 kilometers. So here from all these three cases, we can conclude that distance and displacement can be same. Displacement can be 0. Displacement can be lesser than the actual distance travelled. But here this is also true that distance can never be lesser than displacement. Right? Distance will be always more than displacement. So this is the basic difference between distance and displacement. Displacement is how much body has moved from initial position to final position, and distance is actual distance travelled by a body. So as per our above three references, our displacement will be the shortest distance measured from the initial to final position. Displacement is always from initial point to final position. of an object is known as displacement. So what is displacement? Displacement is a distance from initial position to final position. And now what is a distance? Distance is the path covered by object. Even if it is going to a certain distance and coming back, then also you have to count both the ways. So that is a distance. Displacement can be 0, but distance cannot be 0. Displacement can be lesser than the distance, but distance cannot be and never can be lesser than a displacement. Uniform motion and non-uniform motion. Earlier we have seen that what is a movement, what is a distance and what is a displacement. So today we are going to learn uniform and non-uniform motion. The name itself suggests uniform means it comes with one uniform pattern, and non-uniform means it does not have any pattern. So here uniform means equal distance in equal time. How is it so? So let us understand like this, that car is going and it has covered 5 meters in 1 second. This is the first lap in which it has gone from A to B. This is 5 meters in 1 second. In 1 second it has covered a 5 meters. Now the another lap that is also a 5 meters, it has covered in another 1 second. And in another third lap, it is going 5 meters in another 1 second. So if we will see here, this is a uniform motion. Why it is uniform? Because the car is covering 5 meters in every second. In every second, that means it is per second. What is this? This is a unit of a motion, unit of speed. That is how we are describing speed, that this much distance has been covered in this much time. So here meter per second. Per second means every second. Per seconds meaning is every second. So when I am writing 5 meters per second, 5 meters per second, that means the object is traveling 5 meters per second. So it is covering 5 meters of distance every second. Now here, if I will write that 15 meters per second, that means object is covering 15 meters in every second. In first second, 15 meters, in second, 15 meters, in third second, consecutive third second, it will cover 15 seconds. So if 3 seconds it will travel, then it has likely to cover 15 plus 15 plus 15. So it is 45 meters. It has covered 45 meters in 3 seconds. That is the meaning of uniformity. That is the meaning of uniform motion. This is uniform motion. Now, in other case, when car is traveling 5 meters in 1 second, the second lap is 3 meters. And this is also covering in 1 second. So, in second lap, it has covered only 3 meters in 1 second. Now, again, it is covering 4 meters in 1 second. So, there is no uniformity. Earlier in 1 second, it has covered 5 meters, then 3 meters and then 4 meters. So, there is no uniformity. So, we cannot conclude that after 3 seconds where it has reached. If we have data for all the 3 seconds, then we can conclude, then we can count. Otherwise, we do not know that after the 4th second, where the car will be, how much distance it will cover, because this is non-uniform motion. This is non-uniform motion. In this we cannot conclude. If we have given the data for the speed and its average speed, then we can conclude. Otherwise, like this we cannot guess. Here we can guess because this is a uniform motion. So this is a basic difference between uniform motion and non-uniform motion, that in uniform motion the distance will be equal in equal interval of time, and in non-uniform motion, in every time lapse, the distance will not be equal. So when we are talking about uniform and non-uniform motion, let us talk about the speed. What is a speed? A distance traveled by object in unit time. When distance we are associating with time, that 5 meter it has covered. So in how much time it has covered? How much distance has been covered in what time interval? When we are calculating a distance along with the time, that in how much time this distance has been covered at that time, actually we are referring to the speed. That this much distance has been travelled in this much unit time, and that is meter per second. So here meter per second, meter is distance, and when we are writing per second, that means in this much time, this much distance has been covered. So that's why the unit is meter per second. So this much distance has been covered in this much time interval. So this is a unit, SI unit of speed, that is meter per second. Now from the speed we can also write average speed. Throughout the journey, what was the average speed of that car or of that body? So that is total distance travelled. When the motion is uniform or non-uniform, at that time we can take out the average speed. That total distance travelled by total time taken. Now what is the equation for average speed is V equals to S. S is our distance, the total distance travelled by a body divided by total time taken. So this is throughout the journey. Throughout the journey, what is the distance, and throughout the journey from initial point to final point, what will be the time covered by that distance. So that will be our average speed. So now when speed is there with the direction, that in specific direction a certain speed is there for any object, then we call it a velocity. So what is a speed? Speed is distance in particular time. When this distance in particular time interval is travelled or is covered in specific direction, then that quantity is known as or is defined as velocity. So velocity is the speed of an object moving in a definite direction. So simply, what is a velocity? Velocity is speed with a direction. Now what is our speed? Distance covered in total time. So that is speed, and when speed is coming along with a direction, then that is a velocity. Now speed can be variable because sometimes speed is uniform and sometimes speed is non-uniform. So in that case we can take average velocity. So when the speed is variable, we can take average velocity. Now what we are concluding in average velocity? That object's initial velocity we are taking plus final velocity. That when the object has started moving, what was its velocity at that time, and when object has stopped moving, what was its velocity at that final time. So initial velocity plus final velocity divided by 2. So this we are taking average of the velocity. So we can also write like this, that VAV. AV suggests that V is velocity and AV suggests average, equals to U. U is always referring to initial position or initial velocity. So U plus V. V is final velocity divided by 2. So that is our average velocity. Now what will be the unit of velocity? It is meter per second. Speed's unit is also meter per second. Velocity's unit is also meter per second, and average velocity's unit is also meter per second. So till now we have seen speed, speed with direction, and average velocity. So speed, velocity, and average velocity. What is speed? Speed is distance in time. That is distance covered in specific time interval. Distance divided by time. When speed is coming with a direction, that is known as velocity. Speed with direction is velocity. After that, we have learned average velocity. What is average velocity? the initial velocity plus final velocity divided by 2. And the units of all the three quantities are meter per second. Now let us understand, when velocity will change, then there is a change in velocity that is termed as acceleration. So here rate of change of velocity is termed as acceleration. So here acceleration equals to measure of change in velocity of an object per unit time. How much velocity has been changed per unit time, that is known as acceleration. So here acceleration equals to change in velocity divided by time taken. So A is acceleration, V minus U. So that is change in velocity. Here V is final velocity and U is an initial velocity divided by T, and the unit will be meter per second square. Till now we have seen the unit that is meter per second. For speed and for velocity and average velocity, the unit is meter per second. Here acceleration is meter per second square. And what is acceleration? That is change in velocity divided by time taken. So final velocity minus initial velocity divided by time. Equations of motion by graphical method. So via graphical method we are going to prove the equation of motion. These equations, after this we are going to utilize or use it to solve the numericals. So let us first see this equation, that we are going to prove this equation that velocity, that final velocity equals to initial velocity plus acceleration into t. So this equation we are going to prove via velocity time graph, velocity by time graph. So this content is under CBSE Standard 9 syllabus from the chapter number 8, motion. So let us find out that how we are going to prove this equation via velocity time graph. So let us first understand our graph, that this is velocity by time graph. So velocity we have taken it on y-axis and time we have taken it on x-axis. So this is our travel. This is a uniform travel, and so its line or the graphical representation is a straight line. Now from A to B is a travel. So here when the travel has started, this I have denoted with U. So that is initial velocity. That is initial velocity at A. Now when travel is finished at point B, so that is going to be, if we will extend this point to y-axis, then this is going to be our, E is going to be our final velocity. So A is here of initial velocity and here this is final velocity. So this is E point and this is B point. Now here at B point we have extended that line to time line. So here we will get point C. After this we have just made a bifurcation and we have attached this line to a time line which we have extended, and we have given a point named D. So total points are A, B, C, D and E. This is our point of origin, that is 0. This is not a O. This is point of origin, this is 0. So with all this detail, let us start our equation. So BD equals to BC minus CD. Let us check where is BD. So this is BD equals to BC. BC minus CD. So this is a full line. BC is full line. So when from BC we will subtract CD. This much portion we will subtract. From full line this much portion we will subtract. We will get BD. We will get BD. So what is BD? BD is representing our travel. This line is extending till velocity line. So now, so once this we are writing, after that AD is parallel to OC. AD is here. AD is parallel to OC. These two lines are parallel to each other. Now BC equals to BD plus DC. So BC is here. This is BC. But BC equals to BD plus DC. So these two fragment of BC we have written here, that BD plus DC. Now BD is BD and this DC we have substitute with OA. So DC is this line, DC is this line and OA is this line. So the length of these two lines is similar, they are parallel and they both are equal. They both are same in length. So we have replaced DC with OA. Now BC equals to B. This BC equals to V because that is a complete velocity. So that is V. Now OA equals to U. OA equals to U. So this much is initial velocity and BC if we are taking here, then that is a final velocity, complete. This is complete V. BC is complete V and OA is U because that is initial velocity. So V equals to BD plus U. Here in this equation we are putting that BD plus U. OA is U and here this is V. That this BC we have substituted with final velocity and BD is remain same. So BD equals to, once this U we are taking towards this side, then we will get BD equals to V minus U. In this what we have done, we have put the values from this equation. BC equals to BD plus OA. So BC we have replaced with V and OA we have replaced with U. So now BD equals to U to V minus U. Now what is this? This is change in velocity. Final velocity minus initial velocity. So that is change in velocity divided by time taken. Now BD. Now what is complete BD? Complete BD is acceleration. Complete BD is acceleration. Why? Because it is velocity by time. That is acceleration. So this is A. Now again change in velocity by time taken. So change in velocity is BD. So this much change in velocity is BD divided by time taken. So it is AD. So this is our time. How much time we have taken to complete this much travel? So this is our time. So that much time we have taken here. Now BD is BD and AD equals to OC we have written here. AD and OC because this two line is same. A to D and O to C or 0 to C. Here this is O and here this is point of origin. So here we have mentioned this as a O. This point is O. So O to C. So AD equals to OC. So we have replaced with this two. But OC equals to T. If we are checking here O to C, then this is time taken for the travel. So OC we have replaced with T. So let us put all the value. A equals to BD by T. So BD equals to 80. Once this T will go towards this side, it will go in multiplication. So BD equals to 80. Now, here what is BD? Our BD is this. Our BD is this, that V minus U. So at BD, so here with BD we will put this V minus U. So we will get V minus U equals to 80. This we will get. So now let us frame equation with respect to V, that is final velocity. So U we will take it towards this side. So we will get U plus 80. V equals to U plus 80. This equation we have derived from velocity time graph. Now let us prove the equation for position time relation. So here we are going to find the distance equation. So this equation S equals to ut plus 1/2 at square. This equation we are going to prove from velocity by time graph. So here on y-axis we have taken velocity, whereas on x-axis we have taken time. This is our travel. This is uniform motion, and here this is initial velocity. From here the travel has started. So this is u. This is initial velocity. Here the travel has completed. So that line we have extended till here on velocity line. So that is v. This is final velocity. Now here time required for this much travel is starting from here, from O, the point of origin, then till C. So this much is time required and this much is the velocity, initial velocity and final velocity. Now let us see, when we want to find out the distance, then we have to find out the area under OABC. So here O, A, B and C. This area we need to find out. Then we will get to know the distance, that O, A, B, then C till here, and this much area. So this is something like this. So this much area we need to find out. Once we will find out this area, we will get the distance covered by the object via this travel. So that we have to find out. Now this area has two other areas into that. So if you can see here, this is a triangle. So this is a triangle, this is triangle, and this is a rectangle. This is triangle and this is a rectangle. So there are two areas into this. So this is area of rectangle OADC. So here OADC rectangle's area, and then the triangle ABD's area we will calculate, because this is trapezium. So from trapezium we will bifurcate two area of rectangle and area of triangle. Now area of rectangle, this is area of rectangle and this is area of triangle. So this is OA into OC, that is area of rectangle. Now this is area of triangle, that is 1/2 AD into BD. So this is triangle AD into BD. So that is triangle. Now we know that OA equals to U, OC equals to AD equals to T. This OC equals to AD equals to T. So this much time we have taken for this much travel. So that is T. Now BD equals to AT. From earlier equation we know that BD equals to AT. So we will substitute all this value into this equation, above equation, and we will get this, that S equals to U into T. This OA is U. So U. OC is T. So U into T. Now coming to this triangle's area. So 1/2 T. AD is T. This AD is time taken. So that is T. Now we know that BD is 80. So BD is 80. So once this we will simplify, that S equals to UT plus half AT square. This T are in multiplication. Both the T's are in multiplication. So we will get here T square. So that is how we have proved S equals to UT plus 1/2 AT square, and that too from velocity by time graph. Now we will see the equation related to position velocity relation. So now we are going to prove this equation, that 2as equals to v square minus u square. So 2 into acceleration into distance will give us final velocity square minus initial velocity square. So let us prove this equation via velocity time graph. So as I have explained earlier, this is velocity by time graph, in which our travel is uniform from A to B. This is initial velocity, this is final velocity, and this complete is a time taken for this travel. We have extended this line B to C to time line and B to E on velocity line, so that we can mark a points that what is a final velocity and what is a time taken. Now to find out a distance, we need area of OABC. OABC is O, A, B and C. So this is area of trapezium. It is something like this. This complete area. Into this there are two areas. Area of triangle is 1 and area of rectangle will be second. So this is a complete area of trapezium. Now this is an equation for area of trapezium, that OA plus BC into OC. OA is here. OA plus BC, this into OC. OA plus BC into OC, and then divided by 2. So that will give us area of trapezium. Now we know that OA equals to U, BC equals to B and OC equals to T. So that we are putting it into this. So we will get S equals to U plus V out of the bracket T. OC is T here, time taken, divided by 2. So now T equals to V minus U by A. This we know, but we know that T equals to V minus U by A. So that T equals to, we are putting the value, that S equals to V plus U, that is the same, and for T we are writing here v minus u, and 2 into a. A has come from here. So 2 into a. Now once we will solve this, v plus u, v minus u. So it will give us v square minus u square. This 2a, we are taking it towards this side. So it will go in multiplication. Right? So 2as equals to v square minus u square. So this equation we have proved with the help of velocity time graph. Graphical representation of motion. And under this category, the first category we are learning about is distance time graph. So here in graphical representation of motion, for each and every motion, we have learned till now that uniform motion, non-uniform motion, and we found out the velocity and acceleration. So all those things, when we will plot it on the graph, we will see it via graphical representation, then what all kinds of equation we will derive from that representation. So first category we are taking is distance time graph. So distance time graph means it is distance versus time graph. Whatever will be the first, we are taking it in y-axis, and whatever is the second, that we are taking it along x-axis. So that's why it is known as distance versus time graph. So here we have plotted all the distance, here we have plotted all the time. Time will be in second, and here distance we have taken it in kilometer. So now this is the journey of a vehicle. So from this, let us take one small portion of the journey, and that I am denoting that A and B. These are the points, these dots are the representation of points, that we have taken this data and we have represented those points, and through that we got this straight line. So this is uniform motion because it is straight line. Now to find out for this much distance A to B, let us find out that how much time we have covered for A to B and how much distance we have covered for A to B. So for A to B patch, from point A to point B journey, we are only taking from here to here. We are not taking the full travel. We are taking only for the patch of the journey which has been covered from A to B. So for this, we will check how much distance is there, and we will check that how much time we have taken for or to cover this much distance. So to check that, what we have to do, we can just extend this line towards the time line. So here it is, it is going to be T2, and this point A, when we are extend till this line, then it is going to be T1. So it has started from T1. So this patch is started from T1 and it is going to finish at T2. For example, it has started at 10 o'clock and it has finished at 11 o'clock, like that. Now here, this is our time. With respect to that patch, when we are checking the distance. So here, this is S1. So this point we are extending it till or across the distance line. So this is S1. And when it is going to finish, because we have to check till B. So when it is going to finish, it is going to be our S2. For example, at 25 km we have started and we reached till 30 km. So this is 25 km and we have reached till 30 km. So this patch is total of equal 30 km minus 25 km. So we have to subtract S2 minus S1, like that, because this distance is more. S2 will be always more compared to S1. So we will never get distance in negative. So it is always going to be 30 minus 25. So actually we have covered 5 km during this time. So if we want to find out this distance and this time gap, then V equals to, we will get S2 minus S1 divided by T2 minus T1. Now why T2 we have written it earlier, because T2 is more time, that number is more. So T2 minus T1. So always we will subtract from bigger number the smaller number. So this is going to be our equation. Now when we will find out this distance and when we will find out this time, this is distance by time graph. So we will get here V. When we covered A to B distance So this distance by time graph giving us a speed. So when this object is moving in a straight line in distance by time graph, this is with a uniform speed. So whenever we are taking S2 minus S1 divided by T2 minus T1, that is giving us distance by time. So this is our speed. So to find out speed when we are plotting our graph like this, so for this patch we will find out the speed, that to cover distance from A to B, to cover this much distance we have taken time from T1 to T2, that much time we have covered and how much speed we had at that moment. So we will get it from this, that distance by time graph will give us speed, and this graph represents uniform speed. The second graphical representation is velocity by time graph. So here we have taken velocity on y-axis and time we have taken it on x-axis. So here this is a uniform acceleration. Object is in uniform acceleration, so velocity by time graph will be a straight line graph. So here we got a straight line. This dots represents the data given, which gives us a straight line for velocity time graph. Now for this much interval of the travel we want to find out its distance, that how much distance it has covered. So we have taken here point A to point E. So let us make here triangle. This lines we have extend, these two lines we have extend on timeline, and this 2 points we have extends on velocity axis. So here we got this big rectangle. From this we have divided this and we have given here one point, that is D. So now this is divided into one triangle and one big rectangle. So once we will find out the area of these two, we will get the distance covered. So the full area of A, B, C, D and E we will find out. Once we will find out this full area, we will get the distance traveled. So area A, B, C, D, E will give us how much distance has been traveled by an object. So here two areas we are taking here. So this full area we have divided into two separate areas. This full area we have divided into two separate areas. That this is a triangle and this is a rectangle. So this triangle is area of triangle and area of rectangle. When we will add these two, we will get the complete area under ABCDE. So that is AB plus BC plus half AD into DE. This is the complete area under this, and this area will give us distance traveled by this object via this uniform acceleration. Hope this video has solved your doubt. Comment down below, was it helpful or not. Please give us your feedback to improve ourselves. I'll see you in next video with many more important concepts, so don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.